Okay, so welcome to Lab 3. This one's stoichiometric characterization. So just some announcements and notes from last time. Your post-lab should be graded. Let me know if you have any questions about that. And also, you guys have a test on Thursday. And remember to show up before 6:30 p.m. on Thursday just to get settled in, because the test starts promptly at 6:30. And if you guys are late, then you lose a little bit of time. And I know for these tests, especially the first one, I used the full time. I have office hours at 5 today if you need any help. And then for me, doing all the old tests was really helpful, because there was usually very similar content, and it taught me how the teachers tend to write the tests. And then also for your next assignments, remember to use sig figs. Even if it doesn't say to do it, just remember to use your sig figs. And then for this lab, remember to pay attention and submit the entire lab notebook, because there's been multiple people who have submitted 1 or 2 pages with a few missing. And it's okay to do it once or twice, but then after that, Dr. Shepley said we had to start taking off points, and I don't want to do that to you guys. So we're just doing a stoichiometry review real fast. And the goal of stoichiometry is to balance both sides of the equation with the same number of atoms. As you can see below, this is an equation that hasn't been balanced yet. And then how you balance it is you just have to make sure that both sides have the same number of atoms. And then for finding the limiting reagent, I know this was a question on you guys' pre-lab, and I was able to check a couple, and you guys were doing really well on that. But first you have to determine the balanced chemical equation, and then you're going to convert all the information into moles, and then you calculate the mole ratio. And then once you get the mole ratio, you're going to figure out which one would be used up first. And then I wrote a little example. If you have 5 grams of CH4 and 1 mole of O2, which would end up being a combustion reaction and making CO2 and H2O, the balanced equation would be CH4 plus 2O2 goes to CO2 plus 2H2O. And then you'd convert the 5 grams of CH4 into how many moles you would be. And then how I always like to think of it is I go, if oxygen was all used up, then how many moles of CH4 would be used up? And for this equation, or for this problem set, it was 0.624, which is, or that's how much oxygen is used up if all the CH4 is used up. And so that's less than the 1 mole of oxygen. So since not all of the oxygen would get used up, the CH4 would be the limiting reagent. And then this lab, we're going to be using gravimetric analysis, which is a technique where the amount of a molecule in a sample can be determined by the measurement of mass. And then, for example, you could determine how much water was in a compound by evaporating the water and using the difference in mass to determine how many moles of water was in the compound. And then for this lab, important equations to remember, which I think are also in your lab notebook, or the lab thing, is M1, or moles of substance A times volume of A is equal to moles 2 times volume 2. You guys are going to use that equation today. And then mass loss is equal to the initial weight minus the final weight. And then one important concept you're working with today is going to be finding out how many grams of something is in the solution. And so let's say you have the grams of NaCl and you're trying to find the grams of Cl. You would take the grams of the NaCl, divide it by the molar mass of NaCl to give you the moles of NaCl, and then you would multiply it by the ratio of NaCl to Cl, which is just 1 for this, and then you would multiply it by the molar mass of Cl, which would give you the grams of Cl in the solution. All right, for this lab, the first activity is going to be determination of the formula of a hydrate. The objective will be to use mass analysis to determine the number of waters of hydration for an ionic compound. And then for this, you'll be using gravimetric analysis. The water is embedded into part of the crystal lattice, and then the heat will allow the water to come out of the crystals to create a white powder. And then the hydrate formula would be copper SO4 times an unknown amount of H2O. And this should take roughly 20 minutes. And whenever you're done, just have one group member come back into the main room, and I can just check over and make sure you guys did it correctly. And then for activity B, it's going to be exploring limiting reagents within DNA. And then the objective for this will to apply the concept of limiting reagents to experimental data. Remember to dilute your samples first. You're going to perform a reaction on your solution. This should take roughly 45 minutes. And then here's just a picture of what it's going to end up kind of looking like, I think. So yeah, also after this, just send one person in, and then I can help you guys go over it if you want. And then for activity C, it's just going to be determination of silver nitrate concentration in unknown solution, and then the objective is to determine the concentration. And then this is the precipitation reaction, and this should also take roughly 45 minutes. But yeah, and then reminders for your lab notebook to include the title and date at the top, your lab partner's objective and procedure for each part, any data you collect, any calculations, including your work, just because I've had a problem with some people putting down the wrong answer and then I'm not able to give them any points. And then I don't want you guys to lose points on that. And then any plans or procedures that you might come up with, any notes that you might think are significant. Even if it seems like you're not sure if it's significant, I would just put it, just so you guys can get full points. And then any equations. And then remember, when you're drawing the chemical equations, it's with an arrow, and that you have to include the phase of each element, if it's known. And then remember to check your units, and then to ask if I have any questions, or to ask if you have any questions. And my goal is to at least one time be able to give everyone 100 on the lab notebook. So just let me know if you're not sure if you need to include it, and I can tell you.